Exocet, or Flying Fish in French, is a French-built anti-ship missile that can be launched from surface vessels, submarine, helicopter, or fixed-wing aircraft. It was built by MBDA, a European missile company. The development started in 1967 by Nord. The first name of the missile was named MM-38. The design was based on Nord AS-30, an air-to-ground tactical missile. The first launch of the first Exocet was in 1974, and it entered service 5 years later.
The relative missile is designed for attacking small to medium-sized warships, although multiple hits are effective against larger vessels. It is guided initially in mid-flight and turns on active radar late in its flight to find and hits its target. As a countermeasure against air defense around the target, it maintains a very low altitude during ingress, staying 1 to 2 meters above the sea surface. Due to the effect of the radar horizon, this means that the target may not detect an incoming attack until the missile is only 6,000 meters from impact. This leaves little time for reaction and stimulates the design of closed-in weapon system. Its rocket motor, which is fueled by solid propellant, gives the Exocet a maximum range of 70 kilometers. It was replaced on the Block 3 MM-40 ship launch version of the missile with a solid propellant booster and a turbojet sustainer motor, which extends the range of the missile to more than 180 kilometers. The submarine launch version placed the missile inside a launch capsule. Its price is expected to be around $200,000.
Hi there. Now I will proceed to explain about drag force equation and how we implement it in our research. Drag force equals to 1/2 times density of fluid times the fluid velocity square times area of contact surface times coefficient of drag. Given that the missile travels at 315 meters per second, and from the front the missile looks like a circle, so by using the area of circle, we calculate that the area of contact surface to be 0.0951 meters square. Since the missile travels near the sea surface, we assume that the condition is 1 atm and 20 degrees C. At this condition, the density of air is 1.204 kg per meter cube. For the drag coefficient, since the front of the missile have a cone-shaped design, we assume that its drag coefficient is similar to 60-degree cone, which is 0.5. Now, by substituting all the gathered information and values into the original equation, we calculate that the total drag force to be 2,840.3255 Newton.
I will explain about Reynolds numbers. At low Reynolds numbers, flows tend to be dominated by laminar flow, while at high Reynolds numbers, turbulence results from difference in the fluid speeds and direction.
I will continue with the encountered problems. Based on our calculation, we found that the drag force is high, and also the Reynolds number is high. This problem can reduce the missile range and efficiency
thus more fuel is needed. Okay, when fuel consumption increase, thus the cost will also increase. Improvement can be made by redesigning the missile shape to reduce the drag force and the Reynolds number. Reducing the Reynolds number will ensure smoother airflow around the missile. Reducing the drag force will help increase the missile maximum operational range without additional fuel required.
The conclusion that can be made from this research is that even though this missile is almost perfect in the way it is intended to function, but there is still room for improvement. The drag force and Reynolds number could be reduced to increase its effectiveness. Bye!